All right, we're back. We're on page 3 of note 16 of Calc AB, and we're just using the fundamental theorem. We're trying to apply everything we know. Excuse me, basically at this point. So everything you know. So let's see if we can do it. So evaluate these. Well, this looks nothing like anything that we've done really. So 6 is bigger than 0. So first of all, we're supposed to do the negative and then swap the bounds. And then x plus 1, x minus 1 is just x squared minus 1 dx. And now I'm just going to integrate that. So I'm going to say this is the negative of 1/3 x cubed minus x. And we're going from 0 to 6. So it's going to be negative quantity 1/3 of 6 cubed. That's annoying. X cubed minus 6. And then minus negative of 0, so like minus 0. So that's nothing. All right, if we had to do this, what would we do? I don't really know. I mean, I think I would factor a 6 out first. First of all, you don't really need to simplify this, but I would take a 6 out because you can. Then it's 1/3 of 6 squared. 1/3 of 36 is 12 minus 1, 11, I think negative 66. Does that make sense at all? I don't know. I'll check it in the background on a calculator so that you'll never know. Integral of, I'm doing a trick thing. I'm doing the integral of 1 minus x squared. I'm distributing the negative in from 0 to 6. Negative 66, killed it. All right. This one has the same problem. 2 is bigger than 1, so negative 1 to 2, 1 over x dx. 1 over x dx is one that you memorize, right? So you look at it and you're like, well, what am I going to do? You're going to know that it's the negative natural log, absolute value of x from 1 to 2. So that's the negative natural log of 2, and then minus negative natural log of 1. Natural log of 1 is 0, and that comes up a lot. So negative natural log of 2. So that's fine, negative natural log of 2. But coefficients become exponents, so the negative 1 that's in front can become the exponent of 2. So you might see this as the natural log of 1/2. You could see either of those. So if the lower bound is bigger than the upper bound, swap them, change the sign, and then do your thing. So here, I'm going to swap them and make it 1 to 3. And then I'm also going to make this just 9 to the x, because I think that's easier to deal with, and dx. We can do u substitution, where u is equal to 9 to the x, do all of that, but I remember this, so it's negative, you need a 1 over the natural log of 9. You should review this one every once in a while, because it's just a killer. It doesn't come up often enough to be front and center, but when it comes up, it's there. Let's do this, and then parentheses, 9 cubed minus 9 to the first. And let's just leave that. I mean, we could factor it. Factor out a 9, and you get 9 times 9 squared minus 1. You get 9 times 8. 9 times, what do you get? 9 times 80. So 720. 9, I don't know what I'm doing. I think it's negative 720 over natural log of 9, but I'm going to leave it as it is. And D, I feel like this table, by the way, is no, I guess it is. I was going to say, I feel like it's not centered correctly. So let's say this is definitely just f of x2 minus f of x1, provided x2 is greater than x1. Which I think it's fair to say that that is, but you don't really know. All right. So that's it for those problems. I'm just going to do these. So we're going to use even and odd properties as much as possible, and also shapes of graphs. I see a lot of sines and cosines, and sine and cosine are just shifts of each other. So we should be able to answer a lot of these based on the graph. And also we figured out already that one full hill is 2. So you could kind of do everything based on that. I'm going to actually do this one, but I think the answer is just going to be 1, because when we did cosine, no, we did sine from 0 to pi, and we got 2. So if I go 0 to pi over 2, it should just be 1. It should just be half of that. So this is negative cosine from 0 to pi over 2. Work smarter, not harder. The cosine of 0 is 0. So this is like 0 minus negative. The cosine of 0 is 1. I don't know what I said. Cosine of pi over 2 is 0. So 1. So that makes sense. All right. So now geometrically, negative. So you go like, right? So negative pi over 2 to 0, this is going to be negative 1. Like we can just do them geometrically. We don't really need to go crazy. Sine is odd. And the bounds are symmetric, so that's going to be 0. Smarter, not harder. Always make sure you're doing the smart thing, not necessarily the hard thing. I'm going to like click this thing because my mic says it's not working, but I bet it was working and it just like the icon stops. So whatever. Cosine is just a shift of sine. So cosine is like this. So this is half of a hill. So this is definitely going to be 1. Cosine's even. So like once I knew this was 1, that's also going to be 1. That's 1. And then this, because cosine's even, well, I don't know. You could do 2 times. So like you have a lot of options. You could do 2 times 0 to pi over 2 of cosine of x dx, which is 2. You could do, you know, it's 1 full hill, and we already know that that's going to be 2. You could actually do the work. I don't really advise that, but you could do 2 times sine of x 0 to pi over 2. So it's 2. The sine of pi over 2 is 1. The sine of 0 is 0. So we get 2. You get 2 either way, right? Be smart about them. Think about them. I think there's nothing to do for this other than do it. 1/4 x to the 4th. 0 to 5 is, so 5 to the 4th is 625. So 625 over 4. Okay, so this is odd. So this will be just the negative of the integral from 0 to 5 of x cubed. So this will be negative 625 over 4. And so like you can see that graphically if you choose to make a graph. Never a terrible idea, right? So whatever you get here and here are going to be equal but opposite. So if one of them is 625 over 4, the other one has to be negative 625 over 4. Odd, thankfully, because who wants to deal with that? So this is just 0. Symmetric bounds, odd function, definitely getting 0. All right, let's see. This one I think you have to do. It's so weird to run into a problem where you just like do it, which I don't know if that sounds like a weird statement, but I think it's actually not. All right, so we're plugging in 2, we're going to get 8/3 plus 10 minus, we're plugging in 1, we get 1/3 plus 5. Then we're going to do the thing where we look at each thing like this and this, and then we're going to look at this and this, and then we'll combine those answers. So first, 8/3 minus 1/3 is 7/3, and then 10 minus 5 is 5. So where did things come from? This came from here, or whatever, from that color, and that came from that color. 15 and 7 is 22 over 3. All right, I believe that to be the answer. Now, this is an even function, and so if we're careful, we can use that fact. So if we graph it, not necessarily accurately, but just like graph it. I don't think there's a way that I can like reflect in this, but here's 5, like this, and then this. So whatever I get from -2 to -1, 1 to 2, like this region and this region have to be the same size because they're like the same region. So those have to be the same. So this also is going to be 22 over 3, assuming 22 over 3 is correct. But if it's correct, the other one's definitely that. So is that risky? Maybe. Tangent is an odd function and the bounds are symmetric. So 0, know your properties, know your even and odd. You know, you want to work, you always want to be working smartly. as you go through these, because it's smartly and quickly are kind of similar in this regard. So anyway, that's it for this page. I'll be back in the next one to do some more. So I will see you there.